Good day and welcome to my lecture on the Pythagoras theorem. If you're not already following me daily, you can click subscribe down here. I load videos daily to help you with your maths. It'd be nice to have you on board. Okay, so let's look at the Pythagoras theorem. The most important thing to know is it works for a right angle triangle, and the side opposite the right angle is called the hypotenuse. Now that is the part that we're going to work out. We're going to use this formula down here for Pythagorean theorem. You can see A, B, and C. And at the bottom, the formula says A squared plus B squared is equal to C squared. So a clue is all of this is in a power of 2, which means when we work out the final answer, we're going to do a square root to get it back out of the power of 2 or the exponent of 2. So if you can just remember this formula, this side squared plus this side squared equals that side squared. That is the Pythagorean theorem. Always for a right angle triangle, and we're working out the hypotenuse. Right, so let's look at an example. Here we have a right angle triangle, and we have A squared plus B squared equals C squared. So yes, we know that's our formula, and we've got figures that we've already put in, that A is equal to 3. So let's go write it there. A would be a 3 and B would be a 2. Okay, so 3 squared plus 2 squared equals the hypotenuse. Right, so what does that work out to? Let's go look. So 3 squared is 9, 2 squared is 4, and they equal the square root of the hypotenuse. Let's continue. So 9 plus 4 is 13, equal to C squared still. So we have to now undo the squared to find out what C is on its own. So what happened was we did a square root there and a square root there, and we got 3.6 is equal to C. So if you look here, you'll see C will be equal to 3.6, and we know A was equal to 3 and B was equal to 2. Okay, so it's very simple when you have this formula. You just always have to end by doing a square root to get C in a regular form without it being in a power to 2. Let's look at another one. Here we have, again, right angle. And let's go see what the values are. We've got a 5 for A, and B is 3, and C we don't know. So 5 squared plus 3 squared equals C squared. Okay, 5 squared we know is 25. So it's 25 plus 9, okay, is equal to C squared, not normal C, C squared. 25 plus 9 is 34. So we had to first square root over there to get 34 to 5.83 and to get C to be C on its own. Now what happens if you get one of the sides, you've got C and you've got B in this case. They've given us C and they've given us B, but we don't have A. So we are actually going to make A the subject of the formula simply by using a bit of algebra. We know C is 21 and B is 3, but we don't have anything for A. So let's go work out A by making it the subject of the formula. So we begin by using our original hypotenuse formula, using Pythagoras theorem, and we go put in B and C, but we're first going to put B on that side using algebra. So the way we put B on that side is by minusing it on one side and putting it on the other. So let's do that. We're going to just make it A the subject of the formula. Now we do have A standing on its own, and it's the one that's unknown. So now it's perfectly situated for us to solve for A. Okay, so that becomes now A squared equals C squared minus B squared. Okay. So next, we're going to put the values of C and B in. So we've got 21 squared minus 3 squared. And A squared is equal to 441 minus 9. Now we have to square root to get rid of A squared to make it into A. And A is equal to 20.78. So there you have it. A would be 20.78. The hypotenuse was 21 and B was 3. So you can see how simple it is to actually just make it the subject of the formula. Whichever one you do not have is the one that you go make the subject of the formula. It's quite easy. This is a real gift to mathematicians, this Pythagorean theorem. You can use it for all right-angled triangles. Okay, so if you haven't already subscribed, please do. It'll be nice to see you in the next lecture tomorrow.